Okay. All right. So we're up to here's chapter 2. All right, so we're going to talk about their design principles, the components, and the protocols. Wonder how many current OT systems are still using old protocols? A lot of them. A lot of them are still using Modbus. And people tell me the CAN bus system used in cars is not much better. So you got sensors that monitor physical properties. You got actuators that take instructions and then carry out some physical action. You have programmable logic controllers, which are the first layer of control, controlling these things. And then you got networking equipment, routers, switches, and cables, and so on, which I'm pretty sure means the modern systems are using Ethernet. And then you have operating systems, applications, and firmware that we all talked about, the same as in other areas of IT. And you have SCADA systems, which are the higher level control systems above the PLCs, programmable logic controllers. And this allows the operator to monitor and control the processes remotely. And some people use distributed control systems that manage processes across a large facility, distributing control functions across various subsystems. So the design principles, here's the higher at the top are enterprise level system like enterprise resource planning that will connect this to broader business goals, seeing everything at a high, more abstract level. Then you have SCADA systems to manage the industrial processes, and then you have either PLCs or DCSs here that have direct control of the field devices. And this is what we're mainly going to focus on in the projects I've written so far, although I'm still adding more projects, is the PLC layer. So in this version of the Purdue model, which is not entirely consistent with the previous one, you have level 6 with security management, like risk management and instant response and compliance. Then at levels 4 and 5, you have your enterprise resource planning systems. This is IT. Then you have a demilitarized zone to set a buffer between the external IT network and the internal OT network. And then down here, you now have the site manufacturing operations layer, the supervisory layer, the controller layer, and the physical layer. So this is closer to looking like the ISO model, but I'm a little irritated by the fact that the different diagrams, different descriptions of what's supposed to be the same model don't really line up too well. And I think this is the problem when enough decades pass, everything gets complicated and it moves around, and your organizing models become less and less accurate. So it uses distinct modules. This is always a good idea. It's like you have different modules with different layers of the OSI model, so you can replace one component with another. The disadvantage, of course, is that you might be increasing the attack surface by having multiple different modules working together. Determinism is an essential feature. If the same thing happens again, the same action should result. That's the idea. It's improved performance and reliability, but a highly deterministic system can be less flexible. It might not be able to handle changes or unexpected events. It will just be looking for an event that it recognizes. Resiliency means the system can recover operations and maintain operations even when bad things happen, like hardware failures or power outages or so on. And so you can have ways to isolate issues, ways to do fixes and workarounds, and validate that it's working correctly. This, of course, means you have increased costs to pay for the additional hardware and the additional work required in rolling over to the hardware. So it's in the IT security, you have confidentiality, integrity, and availability, and you worry about things like preventing unauthorized access, risk management, and so on, and your instant response planning is a big part of it. And we're all used to that in all our other courses. That's a complex process. So the key OT protocols again, Modbus is the oldest and simplest and the one most used in our projects. There's a way to OLAY for process control is a way to exchange data between different hardware and software. DNP3 is the one popular in the utilities sector. Ethernet, IP, is another way to do it using Ethernet. implying that at least under some conditions the others don't use Ethernet, or at least they didn't at some one time, and then Profinet, another one. So I've got another Kahoot, and then I'll demonstrate a hands-on project. All right. All right. All right. So which device would open a valve? All right, an actuator. Good. All right, what system distributes control functions across various subsystems? TCS, good. What layer sits between the external and internal networks? As the demilitarized zone, also used in IT networks. All right, what design principle ensures that each time a condition occurs, the same action will result? All right, that's determinism. All right, another winner. And a two-time winner. And another two-time winner. All right. Let me stop this recording.